Hey guys, welcome to day 10. This is Chem 1 on April 8th, 2020. Today's topic is going to be dimensional analysis continued. Alright, so we know what a conversion factor is. It allows us to turn one unit into a different unit. It allows us to go from dollars to euros or pounds to grams. And we've made some conversion factors based on the metric prefixes. That can be a little bit tricky. Also, we've realized that sometimes when you have things that are squared, you need to cancel that out twice. Or if something is cubed, you need to cancel that out 3 times. So at this point, I'd like you guys to go ahead and get your calculators. If you want to follow along, you can. I'm going to go through some of these problems with you, but not all of them, okay? So if you look down here, I've attached copies of the problems. So in this case, we want to know how many miles Micah can travel. So what we're going to do is we're going to create what I call to be the monorail. And the question is, how many miles can Micah travel? So miles is what we're solving for. And we know a couple of things. We know that his car has 16 gallons of gas, and we know that it gets 23 mpgs. Now let's focus on this 23 mpg. That stands for mile per gallon, and anytime you use the word per, that means divided by. So think of it like this: 23 miles traveled for every 1 gallon of gas, and that's going to be our conversion factor, 23 miles per 1 gallon. So we come back over here, and the 16 gallons must be our given. So 16 gallons of gas is how much we have in the car. Now we want to cancel out gallons, and we want to end up in miles. So to cancel out gallons, we're going to put those on the bottom. And we want to end up in miles, we're going to put that on top. And I always like to show unit cancellation. So gallons, canceling out gallons. And then I go back and I plug in my numbers. And if I look at it, the number 1 goes with the gallon. So I'm going to be dividing by 1. And the 23 goes with miles. So I'm going to be multiplying by 23. All right, so guys, in this case, I've kind of set it up for you. You're just going to do 16 times 23. You're going to get a big number, and then you're going to divide by 1. Just remember, dividing by 1 isn't going to change your answer. All right, next one's going to be a little bit more complicated, okay? It says an average experiment requires each student to use 8.5 centimeters of magnesium ribbon. So basically what I'm saying here is that one student, ST for student, is equal to 8.5 centimeters. Now, not really, but if you're trying to get materials ready for a lab, you have to kind of have a starting point. And we realize that one student needs 8.5 centimeters. So that is going to be a conversion factor. Now, I'm going to start off with my monorail, okay? And we want to know how many students. And I know you can't really see it, but there it is. How many students can do the experiment? So I'm going to put ST for students. Now we've got some other numbers. We've got this 8.5 centimeters of length, and we've got this 7.5 meters of magnesium ribbon. Well, the 7.5 meters is going to be our given. So 7.5 meters of magnesium ribbon is what we have. Now, if you see a problem, my unit of students is measured in centimeters. So what I'm going to have to do is I am going to have to convert from meters of magnesium ribbon to centimeters of magnesium ribbon. I'm going to go ahead and let you guys fill in that conversion factor, but I will show my unit cancellation. So meters have been canceled out, and I'm going to multiply or divide by a number to get me into centimeters. And you guys have to figure out what that number is. So which is bigger, a meter or a centimeter? And then the next step is we want to get rid of centimeters, and we want to turn it into students. So we said that one student, that number is going to go on top, is equal to 8.5 centimeters. So you have 7.5 meters. You're going to have to convert that to centimeters. Once you're in centimeters, then you're going to use the students per centimeter to cancel out centimeters, and that should leave you in units of students. So I've given you a lot of the work. The only thing I didn't give you was the conversion from meters to centimeters. So you can plug in the numbers. Remember, you're multiplying by the numbers on top, you're dividing by the numbers on bottom. I typically set the larger value to 1 when I am creating conversion factors. All right, next problem. You are going to convert 14.8 grams of boron into cubic centimeters. Now, we could use the density equation. D equals m over v. And if you want to check your work, that might be a good way to do it. But what I want you to do is try to do this using dimensional analysis. So we are converting grams into cubic centimeters. So our 14.8 grams is converted into cubic centimeters, and I'm going to abbreviate cubic centimeters cm3. So what we have now is we have the density. And let's focus on this a little bit more because this is actually going to be our conversion factor. Basically what this is saying is that 2.34 grams is equal to 1 centimeter cubed. And you can use that conversion factor a couple of different ways. You could say 2.34 grams over 1 centimeter cubed, or you could say 1 centimeter cubed over 2.34 grams. So guys, I'm going to leave that to you to fill in. Just remember, you're trying to cancel out grams. So if you want to cancel out grams on top, you're going to need to put grams on bottom. So you can always use the density equation to check your work. And if you have any questions, you guys can always email me. All right, next problem. We're basically looking at the population of San Francisco. And we know that population is usually an expression of people. And 750,000 people live in an area of 49 square miles. What is the population density of San Francisco expressed in people per acre? So I'm going to come over here, and this is what I want. And I'm going to abbreviate people, PPL, and acre is going to go on bottom. Now, if you go back to the original problem, we know a couple of things. I've given you a conversion from square miles to acres. That's great. I've also given you population. And remember, population is people. So 750,000 ppl live in an area of 49 square miles. So I'm going to put miles squared on the bottom, mi for miles. All right, so we actually don't need to cancel out people, but what we do need to do is we need to cancel out square miles. And how do you cancel out square miles on the bottom? Well, you put square miles on the top. And here's our conversion factor. We know that 1 square mile is equal to 640 acres. So always like to show unit cancellation. Miles squared cancels out miles squared. So basically you're going to multiply the numbers on top, and then you're going to go ahead and divide by the numbers on the bottom. People will remain on top, acres will remain on bottom, and you guys can figure that out. All right, next problem. First thing we need to do is we need to calculate the area of the room. And we're going to assume this room is rectangular, so we can do that, and we can get the length times width. Now, a foot times a foot is a foot squared. Okay, keep that in mind. Now, we've calculated the square footage of the room, but we need to get it to yards squared because that's typically how carpet is sold. So I'm going to set the problem up, and basically our ultimate goal for this problem is to decide how much will it cost. Okay, what is the cost? How much will it cost? All right, and we know that cost is measured in dollar bills. So what you're going to do is you're going to calculate the area of this room, and it's going to be in feet squared. Now, in order to cancel out feet, you need to cancel it out not once, but 2 times. And where we're going to go is from feet to yards. So we're going to multiply by yards 2 times. So I'll show my unit cancellation in pink. Feet squared is canceled out by feet once, feet twice. And then a yard times a yard is a yard squared. But we don't want yards squared. We want dollars. So that's where our price comes in. And our price is right here. So $8 per square yard. We want dollar bills on top, and we want yards squared on bottom. So guys, I've kind of set you up here to where I've given you most of the things that you need. You will have to calculate area. You will actually have to plug in your numbers. And I should also show that my yards on top are canceled out by the yards squared on bottom. So everything cancels out in this case except for dollar bills. All right, next problem. I don't want to give you too much, but I'll give you some hints. This is going to be a long problem. Basically, we want to express the density of water in pounds per cubic foot. Okay, pounds per, that should be cubic foot. Now, what they did give us is they gave us the density in grams per centimeter squared. So, gram per centimeter squared, cubed, sorry. All right, so I would start by maybe converting from grams to pounds. That's pretty easy to do. I have given you the conversion factor to do that. And in which case, we'll show unit cancellation, grams canceling out grams. Now, the hard part of this problem is going to be getting from cubic centimeters to cubic feet. So if you want to do that, you're going to have to cancel out centimeters once, twice, 3 times on top. And I don't know how to go from centimeters to feet, but I do know how to go from centimeters to inches. So I'm going to divide by inches once, twice, 3 times. I'm going to show my unit cancellation in blue for this one. So a centimeter cubed is canceled out 1, 2, 3 times on top. So right now we are in pounds per inches cubed, but we don't want inches cubed. We want feet cubed. And I think everybody in here knows how many inches there are in a feet. So we're going to convert from inches to feet 1, 2, 3 times. I'll show my unit cancellation in green this time. So inches, 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 and inches cancel out. Now what we're left with now is we're left with pounds on top and feet cubed on the bottom. So you guys are going to have to plug in your numbers here. This is going to take 7 steps, and we're going to skip number 7. All right, next problem. An atom of gold has a mass of 3.27 times 10 to the negative 22 grams. How many atoms? This is actually easier than it looks. Okay, so we're going to set up our monorail, and we are solving for how many atoms. Okay, now what we do know is we know how many grams we're given. So we are given 5.0 grams of gold. Now this is actually going to be our conversion. When we say an atom, I realize there's a typo there, but an atom represents 1 atom. So 1 atom is equal to 3.27 times 10 to the negative 22 grams. So this is our conversion factor. Just remember, you want to cancel out grams and you want to end up in atoms. So I've given you a pretty substantial hint by telling you what your conversion factor. Now right here it looks like it's an equality, but realize you're going to have to put that in fractional form. The 1 goes with the atom and the 3.27 negative 22 goes with the grams. All right, for the last problem, you're going to convert 20,000 leagues into inches. I'm really not going to give you much at all, but I will get you started. LG I'm going to use for leagues, and what you want in the end is inches. So we have one conversion from leagues. We can go from leagues to nautical miles. From nautical miles we can go to feet. From feet we can go to yards, or from feet we could go to inches. So you may or may not use all of those conversion factors, but this will be a multi-step conversion. Guys, this can be a little bit tricky. Don't hesitate to email. Remember, you have 72 hours to get assignments done, so if it's not done on day 1, shoot me an email, leave a comment in Google Classroom, or you can always phone a friend. All right, guys, I miss you. I love you.